Welcome to Omega Virtual Learning. This is lesson 2 on trigonometry. If you've not watched lesson 1 trigonometry, I recommend that you watch that before this because this is a continuation. We welcome new viewers to this channel. I'm your online tutor. So in this lesson, we'll be talking about sine, cosine, and tangent and how to use it to work out missing angles in a right angle triangle. And of course, we'll also look at an exam style question. Okay, like we did in lesson 1, we must learn to label the sides of right angle triangle. Opposite is the side directly facing the given angle. Hypotenuse is the longest side, and the third side, adjacent side, is the side closer to the given angle. And if you look at this triangle, opposite this side, hypotenuse, and adjacent, and only hypotenuse is fixed. Adjacent and opposite will be dependent upon the given angle. And like we said in lesson 1, sine is a ratio of opposite and hypotenuse, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. What I want you to understand here is that in working out angles in trigonometry, we are always using the inverse. So we'll be using the inverse of sine, inverse of cosine, and inverse of tangent. It's not, we are doing the reverse, the inverse. And I'll give you an example to explain to you what I mean by the inverse. So don't forget SOHCATOA to help you know the positions of the letters in the triangle. Okay, example 1. We are supposed to work out angle Y. So we start by labeling opposite, hypotenuse. So we check the triangle. We're going to use the sine triangle. Now we are looking for the angle. The angle represents the sine because it's sine of the angle. So we cover the angle sine. That means that y is equal to the inverse of sine of the opposite over hypotenuse. Because it's the sine triangle, we are using the inverse. So y is equal to sine neg1, which is the inverse of opposite over hypotenuse. Replace O and H with the numbers, and this is what you have. Now you pick your calculator to do that. Those of you who are not conversant with the use of the calculator, this is what you're supposed to do. You press the shift function or the second function in the calculator, then you press sine, and you see sine neg1 with a bracket open. Then you type in 8, bring the cursor here, bring it down, you type 20, go to the right of the cursor, move it to the right, close the bracket, hit equal sign, and that will give you the answers 23.58. So follow the steps so that you will not make a mistake on the calculator. Let's look at example 2. We start by labeling adjacent this side, hypotenuse this side. That's the opposite, but we don't need it. So here we check and see. We're going to use cosine because A and H is in cosine. We are looking for the angle, so we cover cosine. And because it's a cosine triangle, we're going to work out x is equal to the inverse of cosine of adjacent divided by hypotenuse. Replace A and H with 6 and 10. Now on the calculator, press the second function or the shift function first. Press the cosine, and you see cos -1 with a bracket open. Type in 6. Cursor at the bottom here, bring it down, type 10. Click on the right side of the cursor to move it to the right. Close the bracket, equal sign. Once you follow this rule, you will always get it right, 33.13 degrees. Third example, this is the opposite side of the angle, adjacent side, so that means you're going to use tangent. You cover the angle, which is the tangent. So that means that x is the inverse of tangent of opposite over adjacent. Then you follow the same principle in the calculator that I've showed you before in the calculator, and you get 59.04 degrees. Now we're going to go through an exam style question. How do we use this in exam, typical exam question? These are just simple examples. Okay, you you can pause the video and just read the question yourself to make sure you understand. A boat is approaching a cliff with a lighthouse on top. The cliff is 80 meters high. The lighthouse is 65 meters tall. The angle of elevation from the bow of the boat to the top of the lighthouse is 60 degrees. Calculate the distance of the ship to the base of the cliff. That's A. B. Work out the angle of elevation from the boat to the top of the cliff. Okay. Now let's try to use some diagrams. So a boat is approaching a cliff. A cliff definitely has to be a vertical line. So let's say this is the cliff and it's 80 meters. Okay. A lighthouse is on top, so that's the lighthouse 65. Right. Now a boat is approaching. So let's put this is the boat. And the angle of elevation from the bow. So this is the bow of the pointy bit, the very top end of it is the bow. When we say angle of elevation, is the angle from the horizontal of the bow to the top. That is the opening from the horizontal. So angle of elevation is the angle between the horizontal and as you open upwards. So if it is 60 degrees, that means from the bow to the top of the lighthouse. So this is 60 degrees. And we are supposed to work out the distance from the base. So we want to work out this. Right. First, we know this distance, 80 and 65. That is the cliff and the lighthouse together makes 145 meters. And we're supposed to work out the distance. So that's a right angle triangle, as you can see. So we can label it, given this angle. This is the opposite side, but that is the adjacent side. So we're going to use the tangent. We are looking for adjacent, so we cover it. That means that D is equal to the opposite side over the tangent of 60. So D is equal to 145 over tangent of 60. And D is 83.72 meters. So we know D to be 87.2 meters. So now, B, you're supposed to work out the angle of elevation from the boat to the top of the cliff. So that means that from the boat to the top of the cliff, we need to work out this angle. It's this angle that we're supposed to work out. We know this is 80, and we know this side is also 83.72, and this is angle X that we're supposed to work out. Let's pull this right angle triangle aside so we can see it clearer here. Right, so this is what we have. We label, that's the opposite, that's the adjacent, that means it's a tangent. And we are doing the angle, so we're going to use the inverse of the tangent. We are looking for the angle, so we convert tangent. So to work out X is equal to the inverse of tangent of opposite over adjacent. And we place O and A with the numbers 80 and 83.72. So tangent -1 of 80 over 83.72. And approximately that will be equal to 43.7 degrees. 43.7 degrees. And that brings us to the end of lesson 2 on using trigonometry to work out missing angles in right angle triangle. Hope you've enjoyed this lesson. Share with your friends, and please hit the notification button so that you'll be alerted of any videos that I post. Look forward to lesson 3, where I'll be talking to you about trigonometry and Pythagoras in 3D. It's a combination of trigonometry and Pythagoras in 3D. That will be our lesson 3. Thank you very much for watching.